Good afternoon, class. We are looking at Chapter 7, Trigonometric Identities and Equations. Section 7.3, Double Angle and Half Angle Formula, 7.5, Solving Trigonometric Equations. And in this section, the objectives are: use double angle formulas to find the exact values, use double angle formulas to establish identities, use half angle formulas to find the exact values, use double angle formulas to solve equations. So reminding you of the properties of trigonometric functions. This is a unit circle, x squared plus y squared equals 1. So a pair x comma y corresponds to cosine t sine t. And therefore, you can see various answers. And of course, x squared plus y squared equals r squared when it's not a unit circle, but centered at 0, 0. Every trigonometric function is an odd function, meaning f of minus x equals minus f of x, except cosine and therefore secant, where f of minus x equals f of x. Fundamental identities, Pythagorean identities, quotient identities, reciprocal identities have been discussed, and now we have the sum and difference formulas. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, and the rest of them follow in the same manner. So these are the formulas that we have looked at so far, and now we want to go with double angle and half angle formulas. I give you the summary, the synopsis of that. Sine of 2 alpha is 2 sine alpha cosine alpha. Cosine 2 alpha has 3 different formats: cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. Tan of 2 alpha is 2 tan alpha over 1 minus tan squared alpha. We'll look at the proof for each case later. So if you look at this one, move the negative 2 sine squared to this side, cosine 2a to this side, and divide by 2, you get this one. You can find half of that. If you cut the alpha in half, you get alpha over 2, then 2 alpha becomes alpha. You can, in other words, you can say, let 2 alpha be x, then this becomes x over 2. That's the idea. What about this one? In this case, if you move the negative 1, make it positive 1, divide by 2, you get cosine squared of alpha. And cut it in half, you get the answer in this manner, just as we mentioned here. Tan, as always, is cosine, sine over cosine. So if you divide the sine by cosine, you get this one. Now, if we cut this in half, we have to cut this in half, and we get tan squared of alpha over 2. And of course, if you want sine of alpha over 2, then it will be this one plus minus the square root and the rest of them in the same manner. So this is the synopsis of the formulas that we're going to come across. We are going to look at the proof, starting with sine of 2 alpha. We want to prove it's 2 sine alpha cosine alpha. You're not responsible for the proof. If you can follow it, it makes it really easier to prove identity. So what is sine of 2 alpha? You're going to write it as sine of alpha plus alpha. So as we look at this formula that we should know sine of alpha plus beta, the sum and difference, if you replace the beta with alpha, what happens? You get sine alpha cosine alpha plus cosine alpha sine alpha. So, and that is the proof, believe it or not, 2 sine alpha cosine alpha. What about cosine of 2 alpha? We're going to do the same thing. We're going to write that as cosine of alpha plus alpha. So cosine of alpha plus beta, we're going to replace the beta with alpha. So in this formula, we do that. We get cosine alpha minus sine alpha, which is clearly cosine squared minus sine squared. So that's the proof. Now, we also know sine squared plus cosine squared is 1, which means sine squared is 1 minus cosine squared. So if I replace this with this, and apply the negative sign, I get cosine squared minus 1 plus cosine squared. Therefore, I get 2 cosine squared minus 1. Let me erase my work. So we proved cosine of 2 alpha is cosine squared minus sine squared, as well as 2 cosine squared minus 1. We want to prove the third one. We also know cosine squared is 1 minus sine squared because of the Pythagorean identity. Sine squared plus cosine squared is 1. So right here, I can replace the cosine squared with 1 minus sine squared. If I replace the cosine here squared here with 1 minus sine squared, what do I get? 1 minus sine squared minus sine squared. That means 1 minus 2 sine squared. That's a proof also. So it's pretty easy to prove things. Now, in this formula, if I want to solve for sine squared alpha, I can move this one to the left becomes positive, this one to the right becomes negative. In other words, let me erase my work again and do the following. Let's move this one this way, this one this way. What do we get? We get 2 sine squared is 1 minus cosine 2a. So what is sine squared? Divided by 2. So we have seen this one in the previous page, the summary page. Sine squared is 1 minus cosine 2 alpha over 2. Now look at this one. I want to get to cosine squared. So I'm going to move the negative one and make it positive. So I get 1 plus cosine 2a equals 2 cosine squared. Divide by 2. You get cosine squared is 1 plus cosine 2a over 2. So that's pretty straightforward. Now, what about, so this is sine squared, this is cosine squared. What is tan squared? Sine squared over cosine squared. Sine squared is 1 minus cosine 2 alpha over 2. Cosine squared is 1 plus cosine 2a over 2. As you can see, both of them have the same denominator. The 2 will drop. And you get 1 minus cosine 2a over 1 plus cosine 2. So tan squared of alpha over 2. Well, cut this in half, then you have to cut this in half. Or if it's hard to see that, you can let 2 alpha be x, then alpha is x over 2. You don't have to use the same variable alpha. You can use anything. And so the same thing happens here. If I cut this in half, I have to cut this in half. So from here, cosine squared of alpha over 2 is 1 plus cosine alpha over 2. And finally, here, sine squared of alpha over 2 is 1 minus cosine alpha over 2. Again, alpha cut it in half, 2 alpha cut it in half. So these are some of the proofs. We're going to continue with more. Again, proving the formulas that were mentioned in the summary. So tan of 2 alpha is 2 tan alpha over 1 minus tan squared. That was mentioned. Okay. How do we prove it? Instead of 2 alpha, we're going to write tan of alpha plus alpha. And instead of beta, we're going to use alpha. So tan of alpha plus tan of beta becomes tan of alpha plus tan of alpha. 1 minus tan alpha tan beta becomes 1 minus tan alpha tan alpha. The top is 2 tan alpha, and the bottom is 1 minus tan squared. So that's a proof, believe it or not. Now, so we mentioned cosine squared, sine squared, and tan squared. So if you want cosine, you have to take a root of this one. Same thing here, thing here with the plus minus. So cosine of alpha over 2 is plus minus the square root of 1 plus cosine alpha over 2. Sine of alpha over 2 is plus minus this expression, 1 minus cosine alpha over 2. And tan of alpha over 2 is plus minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. As far as the sign, as always, you will look at more information such as the quadrant and you make a decision. Now, therefore, we have sine of alpha over 2, cosine of alpha over 2, tan of alpha over 2. And there's also one more sine of alpha over 1 plus cosine alpha. And we will look at that with more details in a moment. So we will look at that. So what do we get here? Where the plus and minus sign is determined by the quadrant of the angle, any angle that you're interested in, for example, alpha over 2. That's important to understand. Now, we want to continue with the proof and say, okay, we said tan of alpha over 2 is plus minus the square root of 1 minus cosine alpha over 1 plus cosine alpha, which is also equal to 1 minus cosine alpha over sine alpha, which is also equal to sine alpha over 1 plus cosine alpha. And these two don't need a plus minus. We want to look at those actually, the proof of those. So going to sine squared alpha over 2, as you recall, it's 1 minus cosine alpha over 2. So if we want to get rid of the 2, we're going to multiply this by 2. So in other words, multiply both sides by 2, this becomes 2 sine squared, and this becomes simply 1 minus cosine alpha. Again, we are going to prove those formulas. We know that tangent is sine over cosine. Doesn't matter. It's alpha over 2, gamma, beta. This must be identical. These three must be identical, and they are. Tan of x is sine x over cosine x. And so we're going to multiply the top and the bottom by something to get this one. So if I want to get from sine of alpha over 2 to 2 sine squared of alpha over 2, I have to multiply this by 2 sine of alpha over 2. And of course, I can't just do that to the top. I have to do it to the bottom as well. When I do that, the numerator becomes 2 sine squared alpha over 2. And the bottom becomes 2 sine alpha over 2 cosine of alpha over 2. So what is 2 of sine squared alpha over 2? We proved it's 1 minus cosine alpha, right? So the top, I'm going to replace it with 1 minus cosine alpha. On the other hand, recall, sine of 2 alpha is 2 sine alpha cosine alpha. Therefore, sine of alpha could be 2 sine of alpha over 2 cosine of alpha over 2. The bottom is sine of alpha. Therefore, you're looking at 1 minus cosine alpha over sine alpha. We proved this one, everybody. How do we prove this one? Very simple. We are going to make it look like that by multiplying the top and the bottom by the conjugate of the numerator, which is 1 plus cosine alpha. So what happens, we write the denominator as a product, and the numerator is a minus b, a plus b, which is a squared minus b squared, so 1 minus cosine squared. So what is 1 minus cosine squared? Sine squared. And sine squared and sine alpha, the bottom goes away, the top becomes sine alpha. This is the proof. All right, let's look at the example. Sine is given as 3/5. Theta is between pi over 2 and pi. We want to find sine 2 theta, cosine 2 theta. And we know all the formulas. For example, we know sine 2 theta is 2 sine theta cosine theta. By the way, pi over 2 to pi, that means quadrant 2. This means quadrant 2. So if sine is given, we can find cosine. Remember, sine squared plus cosine squared is 1. Therefore, cosine is plus minus the square root of 1 minus sine squared. Again, I'm assuming you know the fundamental identities. And so we're going to replace the sine with 3/5. And after we get the answer, we decide positive or negative accordingly. So for now, this is 9/25. 1 minus that. One is 25/25. So it gives you 16/25. So plus minus 4/5. I hope everybody's okay with that. So this is elementary algebra. So one more time. 1 is 25/25, okay. Minus 9/25 is 16/25. Therefore, it comes out as 4/5. And we're going to go with the negative. Why is that? We mentioned this was quadrant 2. In quadrant 2, cosine is negative. So now we are in business. We plug in 2 times 3/5 times negative 4/5. Just plug in. This gives you 25 in the denominator. 6 times 4, 24. Keep the negative sign. Negative 24/25 is the final answer, everybody. Cosine 2 theta is cosine squared minus sine squared. And this one is negative 4/5 squared minus, and this one is 3/5 squared. 16/25, 9/25, we get 7/25. So it's pretty straightforward, everybody. All right, we are going to move on. Cosine 2 theta is 2 minus 2 sine squared theta, and theta is between 0 to 2 pi. That means a complete revolution only. We don't want the general solution. General solution, you add 2 and pi in the case of sine and cosine. So to solve this, we are going to figure out what we have here. Since we have sine squared here, then cosine, there are 2 ways to write cosine of double angle. Cosine squared minus sine squared, that doesn't help. 2 cosine squared minus 1, that doesn't help because we have sine squared. So we write 1 minus 2 sine squared instead of cosine 2 theta. So since these 2 pieces are identical, you don't have to move them. Both of them are negative, get rid of them. And 1 can't be 2, therefore phi means there is no solution. No solution, class. Let me just write it out for you, no solution. Okay, that's the meaning of it. It's an empty set. All right. What about this guy? Sine 2 theta and cosine 2 theta. Well, when you have sine and cosine and nothing else, you can move one of them to the other side. And then by dividing by one of them, make it either into a tangent or cotangent. For example, right here, if I divide both sides by cosine, of course, cosine of 2 theta. So this becomes tan of 2 theta, and this becomes negative. So that's the technique. And we know tan of 2 theta, tan of x equals -1. That makes it in the second and the fourth quadrant. But since if we want to write this for double angle, the way it works, you write 2 theta is 3 pi over 4 and plus n pi. And you divide by 2, you get 3 pi over, okay, you have to multiply this by 2 when you divide. And then this becomes n pi divided by 2. In the case of sine and cosine, we write 2 of them. In the case of a tangent and cotangent, we just write 1 of them, and we go with n equals 0, 1, 2, 3. So if you want from 0 to 2 pi, you plug in 0, you get 3 pi over 8. You plug in 1 pi over 2 is 4 pi over 8. You get 4 and 3, 7 pi over 8. You plug in 2, you plug in 3, and you get the following answers for a complete revolution from 0 to 2 pi. 3 pi over 8, 7 pi over 8, 11 pi over 8, 15 pi over 8. And by the way, I'm sure you noticed if you pick the next number, 4 pi over 2, that means 2 pi, so it goes beyond a complete revolution. Establish identity, write cosine to the power of 4 of theta in a format that doesn't involve powers of sine or cosine. Okay. So cosine to the power of 4 is cosine squared to the second power. And by the way, because it's cosine, you just want to make it a function of cosine. You don't want to go with sine and cosine. And cosine squared, you know it's 1 plus cosine 2 alpha over 2. In this case, 1 plus cosine 2 theta over 2, okay? So having said that, you want to square this. How do you square this? Please understand, when you square a fraction, you also square the denominator. That becomes 4. Therefore, I'm going to take the 1/4 out, because when you divide by 4, that means times 1/4. And the top is a plus b squared. So square this one, you get 1. 2 times the first times the last, 2 cosine 2 theta, and square this one. In other words, just quick reminder, everybody knows this. A plus b squared is a squared plus 2ab plus b squared. So that's what we get. Now, we don't want any power. So if we don't want any power, this is good. This doesn't have any power. This is good. This doesn't have any power. This is not good. So first of all, let's distribute the 1/4. So this is 1/4. This is 2 over 4, which becomes 1/2. And this is 1/4 of cosine squared to theta. Now we're going to change this. And to make sure we understand what's going on, imagine 2 theta is x, okay? So cosine squared of x, that would be 1 plus cosine of 2x over 2, right? So 2 times 2 theta. So the first piece and the second piece, we don't change. 1/4 stays outside. Cosine squared of 2 theta. We're going to write it 1 plus cosine of 2 times 2 theta. Imagine it's x. So 1 plus cosine of 2x divided by 2. Okay? And so let me erase my work. So this is 1/4. This is 1/2 cosine 2 theta. We're going to put the 1/4 times. Please understand this is 1/2. 1/4 times 1/2 is 1 over 8. One over 8 times 1 comes out as 1 over 8, and plus 1 over 8 cosine of 4 theta. Please understand, we are done. We just want to combine these two, and 1/4 is 2 over 8. We get 3 over 8. The rest of them are intact. So 3 over 8, this is half of cosine 2 theta, and this is 1 over 8 cosine of 4 theta. Now, as you can see, we don't have any powers. And that was the idea. Solve the equation. Cosine 2 theta, cosine theta minus sine 2 theta, sine theta equals 1/2. You may recognize this as cosine of alpha plus beta. Let me put it right underneath. Cosine alpha cosine beta minus sine alpha sine beta. So alpha is 2 theta, beta is theta. Take a look. Alpha is 2 theta, beta is theta. So if that is the case, what is this equal to? Cosine of alpha plus beta, cosine of alpha plus beta, cosine of 2 theta plus theta, which makes it cosine of 3 theta. And so 3 theta, if you get 1/2, there are two answers. Pi over 3 in the first quadrant, and then 2 pi minus pi over 3 in the fourth quadrant. So in the first quadrant is pi over 3 plus 2k pi or 2n pi. And in the fourth quadrant, 2 pi minus pi over 3 or 5 pi over 3 plus 2k pi. You want theta, you're going to divide both sides by 3. When I divide both sides by 3, this becomes theta, this becomes pi over 9. Okay? 5 pi over 9. The rest of them are obvious. When they say solve, that means general solutions. You're done. However, if the question was we wanted in the first revolution from 0 to 2 pi, then because it's 3, n must be 0, 1, 2. In the case of sine, cosine, secant, cosecant, we have to go one less, okay? Tangent and cotangent, because the period is pi, we treat them slightly different, as it was mentioned. And you can try it. If you put 0, 1, 2, you get the answers from 0 to 2 pi, the first revolution. An object is propelled upward at an angle of theta, where theta is between 45 and 90 degrees, to the horizontal with an initial velocity of v sub 0 feet per second. If air resistance is ignored, the horizontal distance r that it travels is given by r equals 1 over 16 v0 squared sine theta cosine theta. This can be easily proved, but in any event, we want to show that r is also equal to 1 over 32 v0 squared sine 2 theta. Well, to prove that, we're going to write what's given. This is what's given. Also, we're going to write sine of double angle. Sine of 2 alpha is 2 sine alpha cosine alpha, which means this is half of sine of 2 theta. This piece, half of sine 2 theta. Half and 1 over 16, their product is 1 over 32. So we get 1 over 32 v0 squared the sine 2 theta. That's the easy proof. Find theta to maximize r. Well, how do you maximize r? Well, the only way to maximize it is to maximize sine. Maximum value of sine is only 1. There's nothing you can do about it. So this is maximized when sine is 1. When is sine 1? When the angle, the arc is pi over 2. Therefore, whatever the arc is, in this case 2 theta must be pi over 2, which makes theta pi over 4. So a quick recap. Remember, sine and cosine are both between negative and positive 1. So to get the maximum value 1, then you have pi over 2 for x or 2 theta, and you get the answer. use a half angle formula to find the exact value of sine of 22.5 degrees. And if we go with the formula, first of all, this is a half of 45. Secondly, this is in the first quadrant to understand that. So if you want to go with the formula plus minus, this is quadrant 1. Everything is positive there, and you choose the plus sign. So square root of 1 minus cosine of 45 divided by 2. Cosine of 45, a common angle of square root of 2 over 2. And it's a complex fraction. We're going to multiply by 2 over 2. This becomes 2. This goes away, minus square root of 2. The bottom becomes 4, comes out as 2. So one more time. 2 times 2 is 4, comes out as 2. 2 times 1 is 2. This goes away. So square root of 2 minus square root of 2 over 2. That's an exact answer, precise answer, class. What about cosine of 5 pi over 12? Again, understand this is quadrant 1. How do you know that? Because 6 pi over 12 means pi over 2. Okay, so 5 pi over 2 is in the first quadrant. So this you can use 5 pi over 6 over 2 because 5 pi over 6 is a common arc. And again, we established this is also positive. So instead of plus minus, we just use the plus square root of 1 plus cosine alpha over 2. So we use this one, square root of 1 plus cosine of 5 pi over 6 over 2. Now, 5 pi over 6. Remember, cosine of 5 pi over 6 is the same as pi over 6. You have to make a decision if it's positive or negative. Pi over 6 cosine is square root of 3 over 2. 5 pi over 6 in the second quadrant cosine is negative, so minus. So 1 minus square root of 3 over 2 divided by 2. Again, to simplify this, we're going to multiply the top and the bottom by 2. First, look at the denominator is 4. Square root of 4 is 2. Okay. And this is 2. These two cancel each other. So in this case, I write the 4 and then I take it out. So it's equal to square root of 2 minus square root of 3 over 2. If cosine alpha is negative 1/5 and alpha is between pi over 2 and pi, find the exact value. All of them are half angle. If alpha is between pi over 2 and pi, that means alpha over 2 is between half of those. So half of this is pi over 4, half of this is pi over 2, and that's quadrant 1. And that makes all of them positive. So when we use the formula plus minus, according to the quadrant, we know that we have to use plus. Okay. Since cosine of alpha is given, for sine, we use plus square root of 1 minus cosine alpha and divide by 2. And we replace the cosine alpha with negative 1 over 5. Obviously, minus times minus is plus, with 1 becomes 6 over 5. If you divide 6 over 5 by 2, you get 3 over 5. And how do you rationalize this now? This time we're going to multiply by 5, the top and the bottom. So when you do that, this comes out as 5. This becomes square root of 15. Again, I hope nobody has any problem with rationalization. Cosine is the square root of 1 plus cosine alpha. Basically the same thing, put the plus sign there. So 1 plus negative 1 over 5, which means 1 minus 1 over 5, which means 4 over 5. Square root of 4 over 5 divided by 2 is square root of 2 over 5. Again, to rationalize, we're going to put 5 over 5 inside the radical. These two become 25, comes out as 5, and this is square root of 10. Now, should I use those formulas to get tangent? No, I have sine and cosine. The fastest way is sine over cosine. Can I use those? Yes. Should I use those? I don't think so, because I believe the fastest way is sine over cosine. We already have those two numbers. And of course, when you have a complex fraction, they have the same denominator, they drop. You get square root of 15 over square root of 10. And it's the same as square root of 15 over 10 is the same as square root of 3 over 2, or square root of 3 over square root of 2. It makes no difference. Rationalization. When we multiply the top and the bottom by square root of 2, the bottom becomes 2 and the top comes out. All right, in this case, cosine of alpha is negative 3 over 5. Alpha is between pi and 3 pi over 2. That means alpha is in the second quadrant. And we want to find the following. All right, let's divide, because we want alpha over 2, let's divide everything by 2. This becomes pi over 2, this becomes 3 pi over 4. That's in quadrant 2. So in quadrant 2, we know, for example, sine is positive, cosine is negative, just as an example. For sine, we're going to use square root of 1 minus cosine alpha. And so 1 minus cosine alpha is negative 3 over 5. We are using this one, okay? So 1 minus negative 3 over 5 divided by 2. What do we get here? So this is 1 plus 3 over 5, which is 8 over 5. What is 8 over 5 divided by 2? 4 over 5. We take the 4 out, and we rationalize by multiplying by square root of 5. The top becomes 2 square root of 5. The bottom comes out as 5. For part B, cosine of alpha over 2, we are going to use this formula. Positive or negative? Negative. Why negative? In quadrant 2, cosine is negative. So minus 1 plus negative 3 over 5, which makes it 2 over 5, divided by 2, 1 over 5. Rewrite it in this format. Rationalize. And you get negative square root of 5 over 5. And for tangent, the best course of action is sine over cosine, everybody. Fastest and easiest way to deal with it. So replace the sine with 2 square root of 5 over 5, cosine with minus square root of 5 over 5. As you can see, the denominators, in the case of a complex fraction, they are identical. We drop them. So we get 2 square root of 5. Let me just write it basically here over minus square root of 5. It's just negative 2. Okay, so that would be the final answer. Establish identity. In this case, we start with sine of 4 theta is equal to cosine theta, parentheses 4 sine theta minus 8 sine cube theta. I want to prove they are equal. We start with one side. Normally, we start with the more complicated side. In this case, the more complicated side is RHS, the right-hand side, so we are dealing with that. So notice inside the parentheses, 4 sine theta is in common. If I take the 4 sine theta out, this gives me 1. This gives me minus 2 sine squared. So I get cosine theta, 4 sine theta times 1 minus 2 sine squared theta. Now, by the way, what is this? This is 4 sine theta cosine theta. As you know, 2 sine theta cosine theta is sine of 2 theta. Therefore, this is 2 sine of 2 theta. I hope you recognize that. What about 1 minus 2 sine squared? Cosine 2 theta. Cosine 2 theta. So this one says this is 2 of this. Okay. Sine of 2 alpha, of course, in this case, 2 theta, right? Whatever. Alpha, theta, gamma, those are dummy variables. So the variable of interest here is theta. So 2 sine of 2 theta, and this is cosine of 2 theta, which makes it, now, according to this, imagine it's x again. Sine x, cosine x, 2 of them is sine of 2x. Let me put the x at top. So imagine this is x. So the answer is sine 2x. Which is 2 times 2 theta, sine of 4 theta equals the left-hand side, and you're done. All right, we want to prove this one. Natural log of cosine theta is half of natural log of 1 plus cosine 2 theta minus ln 2. We want to prove that. And to do so, we're going to start with one side, either left or right. The one that is more complicated, clearly the right side is more complicated. And we're going to combine them into a single log, reminding you of logarithmic properties that we have seen. This is the quotient rule. You can go from left to right or right to left. So in this case, we're going to go from right to left, becomes log of x over y. In this case, ln of 1 plus cosine 2 theta divided by 2. So this we'll use the quotient rule here, okay? And become 1/2 remains ln of 1 plus cosine 2 theta over 2. Then what do? Then we use number 7, the power rule. Log of x to the power of n base p is n log x base p. In this case, In other words, the exponent becomes the coefficient. In this case, we're going to go from right to left. So 1/2 becomes the exponent. Recall cosine squared, we proved is 1 plus cosine 2 alpha over 2. So 1 plus cosine 2 theta over 2 must be cosine squared of theta. Cosine squared theta to the power of 1/2, that means cosine theta. And that is the left-hand side. And this is as complicated as it gets. It has trigonometry, it has logarithmic properties, so it's as good as it gets. Cosine 2 theta plus 5 cosine theta plus 3 equals 0. And we want to go from 0 to 2 pi, just one complete revolution. How do we solve that? Well, cosine 2 theta has three different ways. And because this is cosine, we want to go with the one that has cosine only. In other words, cosine of double angle is 2 cosine squared alpha minus 1. So this is 2 cosine squared theta minus 1. Again, why are we using that? Because this is cosine. We combine 3 and -1 into 2. And we want to factor, because this is 2 is actually simple. The methodology is very simple, class. Let me just write it here. So you have 2 cosine theta and 1 cosine theta. And since this is 2, you have no choice but to go with 1 and 2, either both positive or negative. So when you do it in this manner, you have to make sure the middle term, these two, 1 times cosine theta. These two, 2 times 2 cosine theta, 4 cosine theta, they must add up to the middle term. They do, they're fine. So cosine theta is either -1/2 or -2. Let me erase my work. This means cosine is -1/2. This means -2. Now, this one has two answers. Because, okay, imagine it's 1/2 and it gives you pi over 3. Let me just give you this reference arc again. Theta, okay, cosine is +1/2, gives you the reference arc of pi over 3, okay, which is not the answer. Because this is negative, it takes you in the second quadrant, pi minus pi over 3, which is 2 pi over 3, and the third quadrant, pi plus pi over 3, okay, and this has no solutions because cosine is between -1 and 1. Cosine of theta equals -2 has no solution. Okay. All right, let's establish identity. 4 sine u cosine u times 1 minus 2 sine squared equals sine 4u. And of course, the left-hand side seems to be the more complicated side. What is this? If you assume it was 2 sine u cosine u would be sine of 2u. There are 4 of them. So in other words, this is 2 times 2. So 2 sine 2u. This one is just cosine of double angle, cosine 2u. So what you're looking at, 2 sine alpha cosine alpha. Think about this as, let's say, alpha. So 2 sine alpha cosine alpha is sine of 2 alpha. So 2 times 2u, sine of 4u. That's the proof. I hope everybody's fine with that. So that means sine of 2 alpha. Cotangent theta minus tan theta over cotangent theta plus tan theta equals cosine 2 theta. We're going to start with one side. Obviously, the left-hand side is more complicated. And in fact, I don't want to rewrite it again. I don't have room. So I'm going to change everything to sine and cosine. So this becomes cosine over sine, same thing here, minus sine over cosine, same thing here. And as you can see, you can multiply the top and the bottom by sine theta, cosine theta, or you can, take a common denominator. Either way is fine. I'll show you with a common denominator. If you take the common denominator of sine theta, cosine theta here, this becomes cosine squared minus sine squared. This becomes cosine squared plus sine squared. Either way is fine. Or you could have multiplied by sine theta, cosine theta. I like that one better, by the way. So because the denominators are identical, you drop it. What is the numerator? Cosine squared minus sine squared. What is the denominator? Cosine squared plus sine squared, which is 1. What is the numerator? Cosine of double angle, cosine theta. Show that the area of an isosceles triangle, isosceles is when the two sides are equal, therefore these two angles are equal, okay? A equals half of s squared sine theta, where s is the length of one of the two equal sides and theta is the measure of the angle between them. All right. To prove that, we start with the formula we know. Area is half of base times the height. So all you have to do, calculate the base, calculate the height, plug in. To do so, notice this is the base, this is the height. If this is the base, this is half of it, this is half of it. So the entire thing is the base from here to here. This is half of it, this is half of it. If this angle is theta, this is half of it, this is half of it. So we are going to look at one side. For example, this one, okay? Doesn't matter which one, by the way. So we are going to notice that sine of this angle is the opposite, which is b over 2 over the hypotenuse, which is s. So if you do the cross product, s times sine of theta over 2 is b over 2 multiplied by 2, you get b. So b is 2s sine of theta over 2. I hope you can see the cross product will give you that. Cross product, I mean, this is sine theta over 1, okay? And of course, b over 2, you multiply both sides by 2. What is the cosine? Cosine is the adjacent h over s. And we do the cross product again, meaning this is over 1, okay? And so you get h is s times cosine of theta over 2. So plug in here. 1/2, the base is replaced by this, the height is replaced by this. All right, let's see what we do here. We keep the 1/2, s and s is s squared, and we keep the rest inside, meaning we keep the 2, we get the sine, keep the sine of theta over 2, cosine of theta over 2. This is, according to sine of 2 alpha being 2 sine alpha cosine alpha, this is sine of 2 times theta over 2, which is theta. Okay, so it's therefore 1/2 s squared times sine of theta, and that's the proof. A quick recap. This is the base, each side is half of it. This is the angle, each side is half of it. You come up with the sine of theta over 2, cosine of theta over 2. You calculate the h and b, and you put it into the formula half of base times the height, and that's the end of the proof. A rectangle is inscribed in a semicircle of radius 1. So we have a circle. This is half of it, semicircle, and the radius is with one of its side on the diameter of the semicircle. Express area A is shaded region in pink as a function of theta. We start with the basic formula. It's a rectangular shape. Area is length times the width. So let's look at the length. Here's the length, everybody. What is the length? 2 times x. I hope you see this is x. So is this one. So that's 2x times y. So all we have to figure out is x and y. So when we go to this triangular shape with this angle theta, all we have to do calculate the sine and cosine. By the way, this is 1, right? So calculate the sine and cosine, everybody. So sine of theta is the opposite y over the hypotenuse 1, and cosine is the adjacent x over 1. So 2 times x, that means 2 times cosine theta. Y is sine theta. Whether we write 2 sine theta cosine theta or 2 cosine theta sine theta makes no difference for the sine of double angle, okay? And so that's the answer. They want us to show it's equal to sine 2 theta. This is just the formula. So the area as a function of theta is 2 cosine theta sine theta, which is sine of 2 theta. Find the dimensions of the rectangle. To get maximum area, also find the maximum area. Well, if the area is sine of 2 theta, it can only be maximized when sine is maximized. And the maximum value of sine is 1. So that means 2 theta must be pi over 2, and theta must be half of that, or pi over 4, or 45 degrees. Again, just write here the fact is sine 2 theta, and we've chosen 2 theta to be pi over 2. That shows the answer is 1. However, if we want to go with this part, let's say 2 cosine theta sine theta, X is cosine of pi over 4. Y is sine of pi over 4. Both of them are square root of 2 over 2. Area is length times the width, 2 times x times y. 2 times square root of 2 over 2, square root of 2 over 2. I hope you see that. The bottom is 4, the top is 2 times 2, 4, and the answer is 1. However, one easy way to look at this one, if we decided sine 2 theta is 1, and that represents the area becomes 1. This gives us the dimensions as well, okay? Because that's what we want. Find the dimensions of the rectangle to get maximum area. Use double angle formula to establish identity for sine 3 theta. So we're going to write sine of alpha plus beta. And 3 theta is theta plus 2 theta, or 2 theta plus theta makes no difference. And so with that being the case, if we follow that, sine alpha is 2 theta and beta is theta. So plug in. And that gives us sine of 2 theta cosine theta plus cosine 2 theta sine theta. Now, sine of 2 theta is 2 sine theta cosine theta, this one. By the way, because this is sine, we want to make it a function of sine only. So this one is 2 sine theta cosine theta. This one is cosine squared minus sine squared. And so when we look at this one only. 2 sine theta cosine squared. 2 sine theta cosine squared. In other words, combine these two. And of course, you distribute, you get sine theta cosine squared minus sine cubed. The idea is now to change what we can. So we have 2 sine theta cosine squared. Now we want to make it into sine only. So this is 1 minus sine squared theta. So these two add up to 3, by the way. This is 1. So we have 3 of those, 3 sine theta cosine squared. And cosine squared is 1 minus sine squared. Now we're going to distribute. So we get 3 sine theta times 1 is 3 sine theta. 3 sine theta times negative sine squared is minus 3 sine cubed. And this one remains. Now minus 3 sine cubed and minus sine cubed is to add up. So we get 3 sine theta minus 4 sine cubed theta, and that's the proof. If sine theta is 1 over 6 and theta is in the first quadrant, find the following. Well, we just follow the formulas and we try to find them. So for example, the first one, it's sine 2 theta is 2 sine theta cosine theta. And since we have sine, we need to find cosine. And then it will help with the rest of them as well. What is cosine? Remember, sine squared plus cosine squared is 1. So cosine is plus minus the square root of 1 minus sine squared. Replace the sign with 1 over 6. So we get 1 minus 1 over 36, which is 35 over 36. And 35 remains, and 36 comes out as 6. And we use positive or negative. Obviously, we use positive. Why do we use positive? Because the first quadrant, everything is positive. Data is in the first quadrant, and we use the positive. So just plug it. 2 times 1/6 times square root of 35 over 36. We get square root of 35 over 80. Cosine of 2 theta. Cosine squared minus sine squared. So you square each one, and you square this one, you get 35 over 6 over 36, and this is 1 over 36. So we get 34 over 36, or 17 over 80. Sine of theta over 2. Remember, this is the formula, and we use the positive. Why? First quadrant. Plug in. To rationalize this, we're going to multiply the top and the bottom by 6 over 6, because the top is a complex fraction. Now, what happens to the denominator? 12. Just think about it. Square root of 12, square root of 4 times 3, 2 square root of 3. So that would be the denominator. That means 2 belongs to the denominator. What happens at top? When you multiply this one, you get 6. When you multiply this one, you get rid of the denominator. I hope you see why, because the denominator is 2 square root of 3 is 1 over 2, and 3 remains 6 minus square root of 3, square root of 35 over 3. This is algebraic step, everybody. What about cosine? We use the positive again. And I want you to look at these two. These two are identical, except the plus becomes, the minus becomes plus, so minus. So use the same answer. You change the negative to positive here, according to this. So same thing you write here with the plus. Again, from here to here, maybe you want to work on it to make sure that you have no problem with that. We'll establish the identity cosine alpha plus sine alpha over cosine alpha minus sine alpha minus cosine alpha minus sine alpha over cosine alpha plus sine alpha is 2 tangent of 2 alpha. We obviously start with the more complicated side, which is the left-hand side, and it requires LCD, the least common denominator. In other words, combine the two fractions. So this times this is cosine alpha plus sine alpha squared minus this times this, cosine alpha minus sine alpha squared. And the LCD is the product of these two. I'm assuming we have no problem with the with fractions, adding, subtracting, and otherwise. So all you have to do, simplify. First and foremost, the denominator, cosine squared minus sine squared. Cosine squared minus sine squared. Numerator, you square this, you get cosine squared plus 2 cosine alpha sine alpha plus sine squared. Minus, now this one is cosine squared. Maybe I write this one and I apply the negative. This is cosine squared minus 2 cosine alpha sine alpha plus sine squared, and everything changes sign because of this one. So minus cosine squared plus 2 cosine alpha sine alpha minus sine squared. So what happens? Cosine squared alpha minus cosine squared alpha cancel each other. Sine squared minus sine squared cancel each other. 2 and 2, we get 4 of those. I hope you recognize this. 2 sine alpha cosine alpha is sine of 2 alphas because it's 4 of them, there are 2 of them. Cosine squared minus sine squared is cosine of 2 alpha. Sine over cosine is tangent. So 2 tan of 2 alpha.